Hey, everyone. Thanks for joining our session today. And Larry for joining us from Portland General Electric. For all of you that haven't had a chance to meet with Larry, why don't we just jump into some introductions from you first?
Great. Well, thank you, Jim, and appreciate getting a chance to talk with all of you this afternoon about utility business. As far as introduction, with Portland General Electric, I'm the Vice President of what we call Grid Architecture, Integration, and System Operations. And given all the changes that we're going to talk about here in a few minutes, seems apropos. I will say that I grew up in Montana State grad, electrical engineering, and then I proceeded to work for Pacific Power, Pacific Core, long before it became a Berkshire Hathaway company. Was there with them for 17 years, did a little bit of international experience with Japanese utility for 6 months. And then we did hydro projects in Southeast Asia and the Philippines, opened an office in Manila, a little different in terms of utility business. Then came back to the States, went to work for Clark Public Utilities in Vancouver for 7 years, then went over to Bonneville Power Administration, ran the transmission business for 7 years, and then came over and joined Portland General Electric 6 years ago. So that's a quick roundabout for me. They refer to me as kind of the Doug, dumb old utility guy. So been at it a while, love the industry, love what we're doing.
Awesome. And on that note, the industry has changed quite a bit from your early days to where you are today. There's just a lot more modernization that's happening and a lot more dependency on both communications and technology, right?
Absolutely. And
Okay.
that's kind of where, if you don't mind, I'll jump right into
Let's do that.
presentation and talk through it a little bit. Let's give this a try, see if I can get the screen coming up here. Are you able to see a screen?
Perfect.
Okay,
Yes.
coming up. All right, great. Well, good. Well, let's talk about the utility business. And Portland General Electric been at 130 years, and it's kind of fun to think about. We started out in the Willamette Falls Electric Company, built a hydro facility there on the river. At the same time, built the first long distance AC transmission line, and that was from Oregon City down to downtown Portland. This is right at the same time the Chicago World's Fair is going on. And if you recall there, we had Edison and Tesla and Westinghouse, and they were doing a little bit of fighting over AC versus DC. And it's kind of fun to think that the first AC transmission line got built over here in Oregon. And our company, Our Origins, is where that started. And I think on one hand, it's like, wow, people were really innovative and wanting to do something different here. And on the other hand, I thought, well, maybe they built it over here in Oregon because if it fails, they can just erase it and say it never happened. Nobody'd ever know. So to say the least, that's been, kind of the origins of our business has been about making sure or thinking about innovation and use of energy. So where we'd start is also that energy industry is transforming right now, and it's making some really big changes. And obviously what customers are wanting, if you think about what has happened with COVID, reflecting back to some of the early months, I think it was April, we saw a decline in the air emissions by over 17%, and people really noticed it worldwide, that all of a sudden, air was cleaner, and people started to think about even further about decarbonization. And many of you, your companies, as you think about sustainability, and I'll even talk a little bit about wildfires, but we've seen change in terms of climate, change in terms of what our society is looking at and wanting to achieve. So big changes in terms of electric and where our generation is coming from. We were, prior to a couple of years ago, the #1 producer of carbon in the United States. But that changed. Now it's transportation, and transportation is #1. And so we'll talk that, customers are really expecting something different. And for Portland General Electric,
Larry, can I ask you a quick question on that?
yeah.
When you say is that last slide, is that representative of the industry as a whole, or is that there are certain players leading that charge, but there's a long way to go to bring everyone along?
I would say that if you looked nationwide, you're seeing big change across the board. And, you're not going to probably expect the same thing in Houston that you would in Seattle or Portland today, but clearly moving quickly. And, politics play into it, but if you looked worldwide, Europe, much more further ahead than obviously the United States. But we're seeing China now advancing very quickly. So I would say no. This is becoming worldwide. So great question. So for Portland General Electric, we landed on three imperatives that we feel we need to be working on. One is decarbonization, as we just mentioned. The other is electrify. So if we're going to use energy, let's use it wisely. But we have the opportunity to think about cleaner energy and doing that through electrifying, be it homes, buildings, cars, etc. We're going to be looking that direction. And finally, we as a company, just like you all, we need to perform better in this space. So I do like quotes, and so I was like Wayne Gretzky and thinking about, where is that puck going? That's where we want to be. And one more that I like to call out, it's not so much about Steve Jobs and his quote on the left, but if you were to look up these ads from AT&T, the "You Will" ads, and if you were able to scroll deep down in the left-hand corner of that ad, you would see 1994. And at that time, you had AT&T saying, hey, we're going to be able to talk on our wrist and use a phone on our wrist. And, I don't know about all of you, but how many of you can do that today? Obviously you can. And they talk about being able to operate your home, being able to talk as we are right now on a Zoom. And, the thing that was surprising to me, this was back in 1994, and they were thinking ahead. But I also would ask the question, was it AT&T that brought you all these things in the end? And so think about that as we are all advancing and moving ourselves forward. So in my mind, as we think about a utility, it is integrated and it is electric. And there are a lot of parts and pieces that are going to come to play. This is a depiction of kind of the world that we utilities live in right now. On the left-hand side is what I would call the generation side of the business. And, you're not going to probably terms like integrated resource plans and resource regional adequacy and regional planning. Those are all activities that are going on in the generation side and / what has been traditionally transmission. And we've had generation afar. It's been, generating out, let's say, in Eastern Washington or Montana, and then we wheel it via transmission into urban areas like Seattle or Portland. On the far right-hand side is what I represent as the load or the distribution side of the world. So when you bring it into Seattle or Portland, we'd be talking about these issues that are going on there. And the utility world lives in between, and we have operators that are looking at this system, and that's kind of represented by the top. And when you think about this issue, electricity is generated and it travels at the speed of light, 186,000 miles per second. And when you generate it, it has to have a load that's got to match it. And so for a long time in the history, these loads that we have, you get up in the morning and, you start your showers and have breakfast, et cetera, and the loads start picking up and the business is open. We as utilities had to match that, and we keep it, in parallel with that. And during the day, it might fall off and back up in the evening, and then at night it would fall back down again. And we could match generation to load and make sure that was happening all the time. If it doesn't happen, you got frequency problems, you got voltage problems, you get outages, major issues on the system. So that's what we've traditionally done, and it's been very handy that loads move, generation move. But now we've got a situation where not only is the load moving over here, but we got the generation moving over here because we've added renewables, wind, solar. When the sun doesn't shine or the wind doesn't blow, how do we operate this system? And so we are looking to manage both load, if possible, as well as generation now. We need that flexibility on both sides of the equation. And so you'll be able to recognize that utilities want to make sure it's reliable. We want to make sure it's resilient there, it's safe. All those things are still really point on, and it's got to be affordable. Now we talk about equitable, to make sure that everybody has access to it. But finally, there's the innovation side, and that's, I think, where it changed on the generation side. Now it's changing in the loads. And so I'll share a few of those thoughts with you as we kind of walk through the rest of the presentation. We are just now, as a matter of fact, this month, just energized the Wheat Ridge Renewable Facility. That is a wind farm, out here in Eastern Oregon. And it, standard of most wind farms. But what we did was we added solar to it and we added batteries. So it gives us flexibility. We have different, characteristics, and hopefully the capacity of that facility is much greater because you've got storage when the wind isn't blowing or the sun isn't shining, or when you've got excess, you're able to charge up the batteries. And so gives us much more flexibility on what was traditionally a single supply of generation. Yeah, Rick.
Hey, Larry, how much power loss is there when you're putting it into a battery and then taking it back out?
Actually, with batteries, it's pretty minimal. There's not a lot of loss because it's kind of like a transformer in the 90%, 97, 98% range. Because again, your losses are pretty minimal. Over time, degradation of a battery, et cetera, you'll see that. But right now, I'd say it's pretty high in terms of efficiency. Where you normally lose is heat, in thermal to electric or other types of energy sources. But on a battery, actually, it's very good.
Thank you.
Now, the cost of the battery is probably the issue that most of us are. And here's an example to kind of represent that batteries could go in a lot of different places. You're seeing batteries now in homes. When I think about wildfires in California, a lot of the homeowners now are putting batteries in to be able to ride through if they've got a fire threat and what they're calling public safety power shutoffs and actually turning the energy off. We had to do that here for Labor Day for some of our customers, given the conditions and the threat of wildfires. Batteries in substations, batteries at buildings, also batteries that act as buffers for charging. You're going to see batteries in the ferries. I'll say there'll be some of that, but I would say it's probably going to be a lot more hydrogen going in on ferries as well. So that will transition over time. But fundamentally, batteries do give us the ability to store, but it is expensive right now, but it's becoming much more practical and the costs are coming down dramatically. That changes our business, much like oil and gas, where they're able to actually hold in tanks or hold in pipelines. That starts to give us a lot more flexibility in the system. Future continues to change for us. We're putting in a new integrated operating center. And the reason why we're doing that is, one, our existing center is down here in downtown Portland. Both from a seismic perspective, it's a concern to us. But as you've noticed and watched with some of the social unrest, et cetera, doesn't feel really good that we have our nerve brain center in the midst of what can be riots and other issues that are going on. So we're going to be moving it out, but we've got to put together not only what we monitor in the system, but we actually need to watch our networks much more closely. We need to be able to look for physical security along with that. And it becomes a much greater play for us to put all the parts and pieces together and to watch our system much closer, and to give us visibility into our distribution system. Many utilities refer to it Advanced Distribution Management System, or ADMS, you'll hear the term. We want to be able to see into the distribution. Today, we see at a substation level, we have AMI meters that give us reads from meters, but we really don't have information that's out midway through a feeder that says, here's what the voltage is, here's what's going on frequency and the amperage, and if there's an outage, much more granular detail. So we're moving to the position where we want to be able to see all that granularity down into the distribution system. And that plays heavily into, as we get to talking about communication systems and having a digital twin of the system, the electric system, so that you can see, monitor, measure, and be able to operate the system real-time basis. So what else is coming our way? Well, obviously to a garage near you will be an electric vehicle of some sort. And there in 2021, I believe there's 40 different new vehicles that are coming out. And so the escalation of what is known as the transportation, it comes in lots of different varieties. And this kind of depicts a little bit of that. And whether it's, be the autonomous vehicle that will come along, but you can see buses, you can see trucks, even in the air industry, you're going to see it. And I know up there in Seattle, you had the first flight of an electric plane in the Seattle area. So yeah, Rick.
Hey, if I was to get an electric car or any any consumer, how much does that change my electrical consumption at the household?
Well, depending on the car, depending on obviously how your charging habits, et cetera, change, it could be as much as you could actually double the amount of electricity that you use in a household. But you think about, and I'll just say that the fuel efficiency, it's about a third of what you would pay now on a gas vehicle. And the maintenance also, you can eliminate a whole bunch of maintenance on it as well. So some real advantages on that behalf, but you're right about when do people charge, how do they charge? And so that kind of leads into, as we're thinking about electric transportation, these numbers that you're going to see here on the screen, that's just the greater Portland area. So $10 billion worth of potential asset for chargers, for the infrastructure associated with the make ready to facilitate that. That doesn't include the cars. And so by 2050, that's how much investment will be made that we're anticipating. And you can see the number of vehicles, you can see the number of chargers and ports. It will make up 20% of the, what is PGE's total load by 2050, just associated with—
Hey, Larry.
Yeah.
Sorry. I just was going to say, maybe for the team here, just as you're transitioning to this new business model where, like you said, you've got, a lot of renewable generation, right, that is intermittent, right, as opposed to fixed. And now we have, frankly, a lot more consumption, whether it be vehicles, consumers, et cetera, on the distribution side, is just maybe to talk about, I mean, how much better is it for your business if you get really good at matching basically supply to demand?
It's amazing how much better, because we build today to the capacity that's required. And it used to be a winter peaking, now we're actually summer peaking. And so your feeders, all of your substation equipment, you try to match it and go beyond the best peak that you could forecast. And so you watch the trends of the loads and you keep monitoring that, and then you model that and you would forecast. And you'd say, over the next 5 years, here's what the growth rate is on that feeder. And if you got new subdivisions coming in, or you got a new industrial customer coming in, you build around that and you think that way. Well, now we've got loads that are going to flex quite a bit. Or better yet, as you're pointing out, Michael, if I could influence when you charge your vehicle and where you charge your vehicle, that makes a huge difference, because now I can try to levelize the capacity across the system, and I don't have to invest nearly as much in terms of capital for new wires, new transformers, et cetera, to put in and meet that load. Worst thing we can have happen, a lot of people talk about time of use, which can be great, because at nighttime, usually pretty light loads, that's a great time to charge. But if you put in a policy that says, okay, at 10 p.m., we're going to have cheap rates, we're going to cut the rate, I'll just say, in half. And if you own an electric vehicle, you're going to set your car charging to start at 10 p.m. Well, that works pretty good for you, but if you've got 6 neighbors who are all doing the same thing and charging off the same transformer, and you overload that transformer and burn it up, we got a problem. So even though the right idea was to have everybody charge at night, I need house number 1 to start at 10. I need house number 2 to start at 10:15, and house number 3 at 10:30, and and be able to rotate and make sure that we're using the capacity of the system instead of peak.
How accurate is your production capacity relative to consumption? Like, do you have to burn off electricity somewhere to keep the to make sure you're always supplying enough for consumption, or?
Usually you're able to react fast enough that you didn't have to. There is actually what we call the big toaster out in central Washington that BPA has. It is just a bunch of stainless steel coils of wire, and they would flare off energy there every once in a while when it was an emergency, and it's still there in place. But no, we really don't have that as an option. We end up having to flex it, shut down generation, turn something off quickly to match whatever that load is out there. Our problem is if you don't have something to turn back on quick enough.
Yeah.
And we could get into reserves and talk about all those things, but suffice it to say, we today don't have as much flexibility, and that is a real concern when we talk about regional adequacy.
And a lot of, Larry, sorry to interject, clearly you've hit a nerve here because it's inspiring lots of questions, good questions. A lot of what you're doing is reacting to after decisions, things that have happened, demands on the network, and you're reacting to them versus in many cases being proactive. Is that a fair statement?
No, perfect.
Okay.
Exactly spot on with, if I could be proactive and influence so that devices are charging, or I shut off hot water tanks at times, or I can turn your thermostat down 3 degrees or turn it up 3 degrees. I can make a big difference on the system. And when it's 1 or 2 homes, not a whole lot of impact. If it's 1 million homes, you got a big impact.
Yeah.
And so that's why it becomes really important to us as we think about flexible load and having customers participate. And we do that today. We call on it. We've got about 50 megawatts that we used this summer. And the customers that participate actually, there's an economic benefit to them to be able to participate.
Got it. And when you're reacting, is it human intervention that's taking place, or is there automation in your system today that's able to react to these situations?
So there's both. And part of our systems we've been testing. We have 3 test beds in the Portland area. One has been send people text or send them an email and say, hey, between 4 and 7 o'clock tonight, we're going to have a call. And so if you can turn your thermostat down during that time. So some people do it manually. Then others where we have, a connection to their Nest or their Honeywell or whatever thermostat they might have, we can communicate directly using the Internet of Things and broadcast to it and have it operate, move it up 3 degrees one way or the other. That works as well. And we're moving into that. That's kind of our second phase here now, is to do more of that. There's devices that you can put in panels. There's devices you can put on the hot water tank and begin to be able to operate that way.
Wonderful. Thank you.
Okay. Great questions. Also buses, just showing a picture here, TriMet. And here's where, when you start to think about fleets, this is where it gets pretty interesting. You all have seen the ads for Amazon wanting to go all electric with their delivery trucks. And when you think of most warehouses where they have delivery trucks, they have 40 trucks there, and they have lights in the warehouse, and that's about it. So how are you going to bring energy in and be able to work with and be able to charge up all 40 vehicles in some sort of a really affordable manner? And so that's what we've been working on. We've got pilots with Daimler out here. They build their electric buses and trucks, here at Swan Island. And so we've got some demonstrations that we're doing and working to think about chargers. Batteries come into play here because they're buffers where you can charge up the battery constantly and then download fast into a car or a truck. So you know, many of those activities are happening, and we all, as an industry, have to get really smart here on how we operate.
Larry, just a quick question, and just in terms of the paradigm of renewable and storage and those things. As you know, you and I have discussed that, you know, there's so much wind on the Baltic now, right, that they literally are just throwing power away every day because there's no place, you know, to take it, right? And, you know, I guess it's kind of a multi-pronged thing. I'm just trying to understand. I mean, if to your point about having the insight to, let's say, demand patterns, I mean, is it the case that from a storage perspective that literally if you had insight to demand patterns and let's say you knew within 8 hours that there's a likelihood of a certain consumption pattern, I mean, are utilities literally going to start getting in the game of almost like proactive arbitrage to say, okay, well, listen, right now there's no demand for this wind energy, but we're going to just move it into the distribution grid anyway, into storage, and basically bet that it's going to get taken, right? Because there's got to be an expense with just moving it over the transmission lines, right?
So currently what happens today, and I'll use the Western US because we're all connected. We have an energy imbalance market. So from California to Canada, exactly what you're describing happens most every day. And if you've got excess solar or wind out of California, say during the daytime, you're right, they're having to unload that. And how they unload that is they put up negative prices. So basically they're giving the energy away. And so we're up here in Oregon and we're saying, okay, we'll take it, we'll shut our thermal plants down or we'll shut our hydro down during this period of time and we'll buy your, you know, we'll take your energy, you'll pay us to actually take it. And then comes night when the solar shuts off and there's this big sucking sound from the Northwest where energy starts flowing to California to fill in the gap. And, you know, when you think about that, that's not an economy that can last very long. And you're right. So people start putting in storage to try to capture that energy and be able to use it during the day or during night, et cetera, and shave off their peaks. Also, this is where hydrogen starts to come into play. You can use electrolysis to actually generate hydrogen. That's going to be a play that I think people are going to be looking hard at, ways to be able to store the energy in a different way and be able to reproduce it cleanly. So you're hitting on correct that if I have a way to use that energy at the right times, and if I don't really care if I adjust to half an hour, and a lot of industries, you know, need to know dependably exactly and have it there at all times. Other industries, you're right, have that flexibility and can shut off or turn on when the availability is there. We're going to be looking for those that can and can flex like that. Excuse me. This was just a quick chart to say, you know what's happening with technology and the advancements of technology, and it just keeps getting faster and faster as far as adoption, and you all know that better than anybody. Excuse me.
Bless you.
This is I just want to demonstrate for you that, you know, traditionally utilities have used these types of generation, be it thermal or hydro. You had nuclear, you had wind, you had solar coming in. And when I refer to virtual power plant is that flexible load and what you might be able to do in the distribution system. And Michael's heard me say that it was back in actually the 90s when Elon Musk showed up in Montana. He was talking about, early 2000s. He was talking about energy and energy use. And somebody asked him, said, okay, what's it look like for the future? And he said, well, you know, we've got these generation plants that are off in the distance, and today they produce pretty much 100%, and they ship it into the loads. And his forecast was that a third is going to be generated in the cities and with that flexible load, and 2/3 of it will stay out there in plants. And I think he's right. I think that's kind of the way. And if we're going to get to 100% from a decarbonization and clean energy, that's the way it's going to have to operate. And so we see that as a different, and so that brings me to that notion of a digital twin, and what does that look like, that we as utilities are in a unique space here to think about how that information comes back to, and how it communicates, what stays on the edge, what devices are communicating and how they're communicating. And the thing I would point out for this group is that when you see all these different elements spread out around, all of it requires communications. Somehow you're going to have to communicate with all these devices. And so it is critical for us to think about what are those communication links. Utilities have traditionally, our SCADA systems, we've had those in place since the 70s. We've used microwave, we've used fiber, and typical any sort of radio frequencies to be able to communicate with those devices. But you only had maybe 1,000 devices that you were talking to, and you could manage those and you could see it. Now we're talking about millions of devices, and how are you going to communicate with them, and how are you going to bring that in? And in many cases, it's not so much that you need direct control, but you need to be able to influence enough devices to be able to balance, or to be able to bring the load and correct a situation you have with a constraint on your system. So as you can imagine, point out a few things here, like cybersecurity becomes critical, because if you're communicating with all these devices and somebody comes along and starts playing with and disrupting the system, and not a good thing for any of us. Obviously, we're going to have to step into artificial intelligence, machine learning, thinking about how these devices actually, from an analytics perspective, are operating, and helping us to, from a real-time performance basis, latency is going to be critical as we go into the future. And so communication networks, as I mentioned, are going to be really, really important. Utilities have traditionally liked having licensed frequencies because nobody could bump them off. And it was really important to them that that was just a basic fundamental, that when the overloaded circuits, you didn't want to worry about somebody else is going to bump me off the system. And so they bought, frequencies, and we've done that ourselves. And when you think about the auctions that have gone on here recently, and Jim, that was your question, that became really popular because, okay, I could put in my own LTE, and I could think about using that frequency, and I can communicate with devices now. Are they prepared for? There's been only a handful of utilities that have really stretched into this space and started working it, but clearly they want to be able to talk and communicate with devices. Now, do I really need to control, again, a thermostat or a hot water tank in the home with that system? Probably not. I can use the internet for that. But devices that I have connected that are large enough, maybe it's the battery, maybe it's cars and actually charging, and trucks. Then it's a bigger element that I could flex a little bit and work with. So you're seeing us all as utilities start to think about what kind of a communication network is really going to work for us. So again, fundamentals.
Sorry, Larry, to interject. There's been some competing perspectives on enterprise private networks. Some really positive, that it's definitely not a fad, and it's something that's here to stay long term for the reasons you've outlined in utilities, but similar reasons in other industries as well. And then there's folks who are sort of skeptical, like, does somebody really want to stand up their own communications network? I'd love to get your sense, and it's one of the conversations we'll have in questions later, but I'd love to get your sense now, since we're on the topic. Do you see this as being really a fad, or do you see this as really being critical?
No, I think the criticality comes in being able to operate devices that are significant enough to make a difference on the system in a quick manner. Because if I've got a call on something and I've only got 10 seconds to get that done, I need a communication network and devices that I could actually rely on.
Right.
And if I'm just depending on influencing a bunch of loads, am I going to get there? And I think from an actual operating standpoint, it will start this direction. But utilities are still going to use the Internet of Things and make that connection to all those other myriad of devices in homes. I hope that makes sense, but that's kind of
Totally.
where we see it's got to be a device that makes a difference on the system.
And I think it goes both ways, and I'll be quiet after this. On one end, it's the control, right? The ability to either control, react to something that comes up in the network itself. But on the other hand, I think a lot of the core of your problems or the utilities problems is just access to data. All the IoT sensors out there that are generating data that's really important to you making informed and predictive decisions around the operations of the grid itself is really what another big value of this communication network going forward.
That is, probably the bullet point number 2 on this slide,
Right.
advanced visibility in the system. But the third one is just as important, and I'll use wildfires as an example. And now we're putting cameras out there. We're actually putting in weather stations so we can get the humidity, the wind, temperatures, and then we're thinking about vegetation now is no longer just trees that might bump into the line and short it out. We have to think of it as fuel. So what's the fuel levels that are associated with stretches of line? All that's being incorporated. California is in, they're doing it in spades. I mean, it's just amazing how much they're putting out there, but they've got to communicate with all those devices, and their quick and dirty was, I'll just connect it up through a cell service, and I'll just use a normal cell service and bring that information back. And so they're moving quickly, and that's why you see the San Diego Gas and Electric's bidding on, the auctions for the frequency. So know that's also happening. We're putting lots of different sensors now onto the systems that tell us a lot more information, and somehow you got to bring that back. Somehow and then analyzing it once you do have it. But you're going to see millions of sensors going out there.
Larry, what points of leverage do you have for influencing the when a consumer installs a high draw device in their house, like a car charger, so that you can, maybe help them manage that charger?
Well, there's a couple of things. One, if tradition would be you've got a tariff as a regulated utility that would say, okay, I'm going to offer to all the residential customers a charger at a reduced price if they'll allow us to monitor the usage and influence the usage. So either a reduced price or even there's lots of discussion about maybe it's a flat rate, that you're able to use and charge your vehicle. But there's got to be an incentive. There's a two-way street here that benefit to the utility in terms of the system. So for all customers to benefit, as well as the individual that owns the car and the charger.
Thanks.
Hey, Larry, it's Michael. I just want to ask, just kind of a general business question. So looking at the slides that you presented, your dance card is pretty full. There's a bit that you guys have to do, right?
Yeah.
And I think that, adding on, running your own communications network is obviously, another, bit of work as well. But I understand, in terms of control, security, resiliency, all these sorts of things to be able to do your business. I get it. But is there also, I guess it's kind of two parts. Is there a motivation too, just given, I guess, the traditional business model of utility that says, hey, listen, hello, regulator, we need to, invest in this capital project, right? Because it basically will, it gets done what we need to, let's say in this particular instance, hasten the transition to renewables and help us bring in transportation electrification. But how much is the motivation, about the financial model as well? And I guess, if you look at regulation, is there any new trends that say, hey, you don't have to do this all yourself. We will look at new, models that allow you, let's say, to embrace, let's call it a network as a service and all these sorts of things. So you don't have to go get so far away from your knitting, but yet you get what you need to run your business. Sorry, that's a big question, Larry. I don't know if that makes sense.
Let me just use transportation electrification as that example. And if it's going to be 20% of our energy usage going into the future, it means that's a lot more revenue, if you want to think of it that way, that a utility would get based on that usage. And if you do it smartly and use the capacity you have currently in the system, you can bring it on for a whole lot cheaper than if you have to go rebuild the whole system. So economically, absolutely, it's a real benefit for all customers if you can manage that and bring it in a wise manner, have the digital capability to influence the charging and when and where. You think about, there's a great example of Snohomish and Seattle City Light we're both talking about up there, where you got quite a few people that live in Snohomish and Everett area traveling into Seattle. And Seattle City Light has extra energy from their hydro facilities, et cetera. Snohomish was short kind of on their side. And so the thought was, well, instead of building a transmission line from Seattle to Snohomish, what if we incented people to charge their cars at work when they're in Seattle versus charging their cars at home? And, it's things like that we have to think differently about our business that can really make a difference, from an economic standpoint. And again, that takes cooperation between utilities as well to be willing to do that. So it's a great question, Michael, and I think our old traditional regulation needs to morph with this as well. You've got to think about your stakeholders. So we've had Bob Jenks with the Citizens Utility Board here talking with us extensively about transportation and how do we approach that. We've had a lot of community groups that represent either people of color, people of poverty, working with us to say, how do you make this equitable and how do we work with customers? And so a lot of all those attributes have to be kind of thought about as we move forward here.
Thank you, Larry.
I'm still stuck on the 20. I'm sorry, I'm still stuck on the 20% is transportation. I mean, imagine your house, you've got lights on, right? And then maybe you're running a washing machine and a refrigerator. Then you have this 2-ton vehicle that you're going to whip up to 60 miles per hour and send 20 miles away and back. It just seems like a lot more power suckage than home.
You're correct. Like I say, it could be as much as what you normally use in the house. And charging batteries, it accelerates at the very beginning period, and then it slowly degrades off of that, in terms of slowing down its charging. So what if your devices between what you had in the home and your car actually said, okay, I'm going to manage the loading on my service to my house to be maintained at this level. So until my washer shuts off and my family goes to bed, I'm not going to turn the charger on because the load didn't come down on the house. So now I'll charge the vehicle after everybody's gone to bed. So, again, the intelligence associated with devices talking to each other is going to be a powerful play as well.
Larry, IoT as an industry has its ebbs and flows, right? It started off as a great idea. Some people did lots of deployments. My sense of it, this is that it's not hit its stride yet, but given everything you've shared with us today, it's a pretty critical part of your business model going forward, right? Because it gives you access to data in the field and then also gives you the means to control operations on the network itself. Is that a fair way to look at the opportunity from an IoT perspective?
Yeah, I believe it is. Again, millions of devices. Again, getting smarter, kind of the plug and play. The better we get at that, the more assurance and reliability we have associated with those devices.
Perfect. And so thank you for that. And just to go deeper a little bit, there's sort of a binary way to look at IoT. There's the one that says, hey, I'm going to put a temperature sensor or some sort of a sensing device. And then there's hopefully the next version of this, which is I'm not just sensing something, but I'm actually going to take action on it. If you were to sort of dream up your own needs, what are the things that you look for in IoT going forward that will be interesting and needed in your industry for what you're doing beyond, let's say, what it does today? If there's a wish list of capabilities that you would love to have, what would those be?
Well, it does, as you say, it senses what's going on and it will adjust itself based on conditions of the system.
Right.
And
so autonomous capabilities.
That was tested up there on the peninsula. I recall, trying to remember what years that were, but we were doing that with transactive energy. So send it signals and have it respond. It was pretty effective, but those were early days. You didn't have a lot of reliability, and who's going to go out there and reprogram, or how many times do you have to reset your Wi-Fi at home? So those things aren't available at that point. So,
right.
So, yeah, how do we gain resiliency with those devices as well?
Right. I had another big question for you, which is the industry has really come a long way. And no offense, but the industry is also kind of known as being somewhat of a laggard more than an innovator. But yet here you are innovating quite a bit just in terms of the new demands of your business. What advice could you give to startups in terms of how to best approach working with a PGE or utilities generally? What are the right ways to approach opportunities?
I think you definitely want to build a relationship with a particular utility. Okay. That's willing and wanting or has a desire to think about it differently. Many utilities have scaled back. I can go back to the 80s and going into the 90s. Utilities said, we're going to get out of the R&D. That's not our business. We're going to rely on manufacturers to do all of that. And so we scaled back and stopped doing a lot of those activities. And it wasn't until probably 2010 timeframe where utilities started getting back into it. I mean, we spend less than 0.5% of our gross revenue on R&D activities. I mean, the dog food industry does like 3%. So, how do we as an industry start to ramp up? And you're seeing a lot more interest now. You're seeing a lot of consortiums that are coming together, incubators, et cetera, that are focused in this area. So one would be, again, find the willing partner and begin to work that way. Find the industry trade associations also that you can link up with and think of it differently, how you might enter into that space. Clearly, things like the national labs, et cetera, are great places to maybe link up and think about. And we've got Pacific Northwest National Labs right there in the Tri-Cities. So we do a lot of work that way as well. But you do have to find a utility that's willing to be a partner.
Hey, Larry, this is Dirk Scow here. I'm with a company up here in Seattle called Tactile, and you wrote out our magic words in slide number 20. That was augmented reality. We actually do a lot with utilities. We've worked with AEP. We've worked with National Grid. We're working with hopefully 3 of the national labs on how you deploy this technology for upskilling and for maintenance of operational continuity. Just wondering, when you threw that up on your slide, you didn't really talk to it. How are you guys thinking about AR and what role do you see it playing for you guys and in the industry as a whole?
Well, part of it starts, I think, with customer disaggregation of data and understanding and giving yourselves better forecasts and understanding the loads and what individual customers are doing. That's one space that we're beginning that work in. Also in our plants, we're doing a lot in that space to monitor and watch and forecast failures, if you will, and thinking about the asset and what its characteristics are, and as we start to see things and as it learns from itself, deciphering what's good and what's bad, when we should be alarmed or not. So thinking about risk levels, how do you approach those assets on the risk basis?
So is that sort of basically real-time virtual dashboards powered by IoT?
Yep.
Okay. Are you guys thinking about
fire mitigation is another area that's very interesting to think about, the analytics associated with construction of the utility service and what that condition of it and all those attributes, the fuel that's on the ground, and then the variables that are going on, whether it be again, temperature, wind, humidity, etc., and causing you to make a decision whether I'm going to turn that particular line off or not.
Okay.
And that's what California is going through, virtually every day now.
Okay. I have some other questions. I might try to connect with you over email. Thanks.
Great. Thanks.
Hey, Larry, Jags here from California. I had some mixed experience working with EPRI, back to the earlier question Jim was asking. What is your recommendation? Is EPRI a route to the utilities, or go directly to build the relationship?
If you've got, and again, Jags, I don't know exactly what types of devices or things that you're doing, but EPRI can be really good if you link up with the right, I'll say, researchers, and make sure that they've got a real business thought in mind, how this is going to be applied, because they will test it really, really well, and when they come forward and say, this is a great product. Now they do have their Incubate Energy program as well. And we participated this last year for the first time, where, again, businesses come in. We actually, as utilities, said we'd like things in these 5 areas. And then, different industries would put their applications in. And then we chose the top 16, and then are now looking at and evaluating the results of that here from this summer and fall. But you do need the right partners there, and we tend to help some make the right connections there.
Got it. Our business is we build tools to shrink neural network models, AI models, to small sizes, so they can run on very energy efficient devices, on a Raspberry Pi like devices, right? Like small devices across. So.
Wow.
Excellent.
Great.
Thank you.
Last question.
All right. Shuram here. Hello. Thank you for that. That was very, very, very interesting. I'm with GenXcom. We build RAN solutions, mesh solutions, particularly. And our specialty is interference cancellation. We make interference disappear. Very quickly, you mentioned reliability, and I totally get that. What type of latency and what impact does latency have, both on the overall controllability as well as on the markets, if that matters at all? And is a low latency mesh of importance to you?
Great question. Kind of gets back to a little bit of what I mentioned as to how much impact can it have on the system. So if it's protecting a substation transformer, for instance, and you've got, I think of our typical protection schemes, and a fault on the transmission, the amount of energy at 10,000 amps at 500 kV, you blow equipment apart if it's more than, millisecond. So latency becomes really, really important. But if I'm dealing with a home and I've got a voltage sag that's starting to happen on a distribution circuit, and I can influence enough load to come off in the next 10 minutes, I might be okay.
Got it. And these are like PMUs, and these are measurement units instrumented across. And this is very, very interesting. Very interesting.
That much money into, putting in PMUs, then your latency needs to be really, really short. No,
I totally get it. In fact, I worked on PMUs for a part of my research. So I would love to connect with you on this, because this is one of the best use cases for ultra reliable low latency mesh, or what we call URLLC mesh.
Hold that thought, Sriram, because I think we might have a way to do that in short order. Hey, Larry, thank you so much. You're a busy individial, taking on more responsibilities at PG, so we don't want to take any more time than we've asked for. So thank you so much for your time today. And thanks for the great questions, guys, who were able to dial in. We certainly appreciate you embarking and sharing your vision with us and your wisdom. Thank you.
Thank you all.
All right.
Thanks, Larry.
Have a great rest of your day.
Lab folks for putting this on. Thank you.
You're welcome. Thank you. Cheers, guys.
Thank you. Thank you.